Okay, so meanwhile, I'll just start the meeting. Yes, so this was the given problem, what was asked previously, where y of t is the output and x of t is the input there. So in direct form 2 realization, I repeat, so the system 1, the subsystem 1, what was realized, and the subsystem 2, which is being present, okay? So subsystem 2, which was being present, so it has to be interchanged. So the coefficients which is governing the subsystem 1 and subsystem 2, it has to be interchanged, and then you have to realize it in direct form 2. So the direct form 2 realization, where you are going to find out the number of integrator blocks. Okay, can anyone tell me how many integrator blocks that we need to provide?
2.
Yes, how many integrate? Yes, exactly. So 2 integrator blocks that we are providing, and how we are going to understand is depending on the maximum operator. So maximum number of integrators that you are going to find in the equation. So you are going to find 2 and 2, 1. Yeah. So out of 2 and 1, 2 integrators is said to be maximum, right? So I'll be having f of t as the function to realize the integrator. So f of t, this would be f of t with an integral dt. Next one, I'll be integrating again f of t dt. Twice I'm integrating, and it is f of t dt there. So next one, what you need to realize, you need to see to it that the system 1, subsystem 1, this is the subsystem 1 and subsystem 2 in direct form 1 realization. So you have to interchange it. So after one of the integral, you have -5, and after the second integral, you have -4. Okay, so -5 and -4. So this over here, this is -5, and this over here is -4. Okay, so I can realize it like this. So I'll be calling a summer block here. So this summer block, what I'm going to represent, so this is the summer block which is being present to have -5 integral f of t dt. Next, you are going to have -4 double integral f of t dt. Okay, so now I am left out with the input. So I'll be specifically talking about this input. So I need the output as f of t. So very much clear. Okay, so I mean the function, whatever that is there, that is f of t, will have the output. So f of t can be realized as f of t, that would be equal to, so it is just like back working. Okay, so I have an output called as f of t. I'll be calling a function. So from that, I'll be having the integral operator being present there as a block. So this integral operator, once you multiply with the scalar multiplier as -5 and -4, subsequently, you will be getting f of t. Okay, so f of t would be equal to x of t -5 integral f of t dt. Next, -4 integrated twice f of t dt. Okay, so this is what we are having in case of f of t that is present here, right? So this acts as the intermediate output. F of t acts as the intermediate output. So from f of t, I need y of t as the output. Okay, from f of t, I need y of t as the output, and I need to have the summer being present, right? So most of you will go wrong and you will directly connect from f of t to the summer. Not required. See here, I already have f of t. F of t is being present here, and I need to have the system component. After one integral, I have 3, right? I have 3, and after two integral, I mean, after two integrator blocks. So this is integrator block 1, and this is the integrator block 2. So after one of the integrator block, I multiply it with 3, and I just give it to the summation here, right? So next, after integrating it twice, I have one more integrator block. After integral f of t, I have double integral f of t dt, and I'll be multiplying with 1. So that's the reason why this function, so f of t acts as the input to y of t. If you observe carefully, even though it is the intermediate output, so this f of t will act as an intermediate input to y of t. Like you are having one integral that is being present there, and that integral you are going to have two more blocks like that, and f of t here, it is being acting in this direction. So whatever that we present in the first one, that was the other way, right? So if you observe carefully, f of t which was present, so f of t is the intermediate output. So from f of t you need to produce y of t, or you need to get y of t. So y of t, if you want to get it, you will be having the f of t acting as the input, right? So if you can observe here in the function what I'm going to represent for direct form 2, so subsystem 2 and subsystem 1, so that is y of t. So this here is f of t. Okay, so this here is f of t. So I'll be having two integral operator. So after the first integral operator, I'll be getting 3 times integral f of t dt. Next, double integral f of t dt, right? So now I'll be having the output of this added, and I'll be getting y of t, right? So how you are going to write y of t? Yeah, what's the equation that you are going to? Y of t would be equal to, yes, can anyone tell me? 3 times integral f of t dt plus integrated twice f of t dt. So this is y of t here. Okay, fine. So I hope this is clear to you. So integral that is being present there. 1 minute. Just a moment. Okay. So this is how you can realize the direct form 2 realization. Okay, so that's how you can represent the direct form 1 realization and the direct form 2 realization. If you observe carefully here, so you will be having the integral, that is y of t, that would be equal to minus 5 integral y of t dt minus 4 integrating it twice y of t dt plus integrated twice x of t dt plus 3 times integral x of t dt there. So first what you are going to do in direct form 2 realization, you are going to have f of t being present there. So how many number of integrators that you need to check? You need to check with 2 integrators there, right? So you need to check with 2 integrators. After these 2 integrators being formed, so you need to have the intermediate output, that is f of t. So you are going to have integrator that is being present there, and f of t would be equal to x of t minus 5 times integral f of t dt. So like what you are going to get here, you are going to have an intermediate output as f of t. So that one you need to give it as an input to the second subsystem here, right? So you are just interchanging the coefficients of subsystem 1 and subsystem 2, what we did in case of direct form 1 realization. Okay, so I think I'm facing a bit of technical issues here. So let me re-log in. Yes, sorry for the inconvenience. Okay, I think we can go to the next problem. So the next problem goes this way, where you will be having this one, I'll just give a connecting problem to you. It would be quite easy for me to do it. So I can give this problem as one of the problem that you can try. D by dt of y of t plus 5 times y of t, that would be equal to 3 times x of t. Okay, so I can give this problem to Vindhya. Okay, so she'll be solving it using direct form 1, using direct form 1 and direct form 2 realization. Okay, I can give it. Just a moment, I think. Okay, so yeah, so using direct form 1 realization and direct form 2 realization, so Vindhya will be solving this continuous time signal, that is y of t and x of t. So this differential equation of degree 1, so she will be solving it and realizing it using direct form 1 and direct form 2 realization. Okay, is she there in the meeting? I think she can confirm. She can do it.
Yes, sir.
Okay, thank you. So the next problem goes this way, where I'll be solving it in right now. So where I'll be having d squared y of t divided by dt squared plus 5 times d by dt of y of t plus 4 times y of t, that would be equal to d by dt of x of t. Yes, so this is one of the differential equation that we are going to solve using direct form 1 realization and direct form 2 realization. Okay, so now what we did, we have to integrate once. Integrate once, step by step I'm going, integrate once. Yes, so what you are going to have? So you are going to have d by dt of y of t plus 5 times y of t plus 4 times integral y of t dt, that would be equal to x of t. Next, integrate once again. Integrate again. Okay, integrating it again. So what I'm having, so y of t plus what I'm going to have, 5 times integral y of t dt plus 4 times integrated twice y of t dt, that would be equal to integral x of t dt. Okay, so this is what you are going to understand as y of t plus 5 times integral y of t dt plus 4 times double integral y of t dt. So that's how we are going to realize the given differential equation, and you are going to integrate it. So integrator is the block that you are going to realize using the direct form 1 and direct form 2 realization. So y of t plus 5 integral y of t dt plus 4 integrating it twice y of t dt, that would be equal to integral x of t dt. Okay, I'll be rewriting it again for my convenience. Direct form 1 realization. Direct form 1 realization. Okay, so the direct form 1 realization, I can realize it quite easily. So I'll be having y of t as the output, and what you are going to have, integral minus 5 and minus 4. So minus 5 integral y of t dt minus 4 integrating it twice, that is y of t dt. And next one, what you are going to have, single integral plus integral x of t dt. Okay, so in order to realize this direct form 1 realization, so I'll be going for the number of integrator blocks in the input, number of integrator blocks, number of integrator blocks, that is 1 for the x of t input, and the number of blocks that is there, that is 2 for the output there. So totally I'll be having 3 integrator blocks. So I need 3 integrator blocks to realize direct form 1 realization. 3 integrator blocks. 3 integrator blocks. Yes. So I have these 3 integrator blocks that I need to realize. So in order to realize these 3 integrator blocks, what do? I create the input. as x of t. Okay, so what do I do here? I create an integrator as an integrator block 1, integrator block 1. So now it would be quite easy for everyone. You are just looking at some blocks and you are just writing some summation and then you are getting the output. But when it comes to the examination point of view, it would be really difficult. Like you'll be having convolution, you'll be having discrete time Fourier transforms and everything. So see to it that you understand the concept clearly. Okay. So now I have the integral, that is integrator, that is one of the integrator block, that is integral. What you are going to get it as the output integral x of t dt. Okay. So now I'm going to get the integrator as 1. So that is the output integral x of t dt. So I need to have a summation here. So I'll be having a summation like this. So this summation over here will give me the output. So that is nothing but I'll just add a summation and I'll be getting integral x of t dt. So there is no x of t here. If x of t would have been written, I'll tell you, plus if you can find x of t like this, so then you would have added. Okay, or else there is no x of t function here. That's the reason why I can erase this line. Okay, so this is not required. This is where most of you will go wrong. So from x of t, you directly give it to a summer. It is not the reason, right? So it is going through the integrator block and then you are finding the output here. So yeah, sorry. So this is the summer block that is there, summing block. This is the summing block. Okay, so if I have this summing block and this is the output of it, this forms the entire subsystem 1. This is the subsystem 1. Okay, so now this is the output of the subsystem 1. So what do I need to do? I need to have the output as y of t and I have 2 integrator blocks that is being present there, right? So 2 integrator blocks that is present. So what do I need to do? After one of the integral blocks, I have minus 5. Yeah, minus 5. Okay. So next, after one or 2 integral blocks, I have minus 4. So what do? I create a summer here. So this summer will have those 2 blocks. Output of those 2 blocks, that is minus 5 integral y of t dt. Next, minus 4 integrating it twice, y of t dt. So that you are having it as the output there, that is y of t. So this function here will have the subsystem 2. This is subsystem 2. Okay, this is subsystem 1 and this one is subsystem 2. So these are the 2 subsystems which are being present there if I want to realize it for direct form 1. So using the direct form 1 realization, I can have 3 integral blocks and these 3 integral blocks are being placed in such a way that the required output y of t is obtained. So this is what you are going to follow for the direct form 1 realization. I hope everything is clear to you. So this is how you can follow it and you can have the summation, right? So this is plus here, definitely. I think if I missed it, and definitely it is plus here. Okay, so that's how we are going to realize the direct form 1 realization for the given differential equation. Okay, so let us move on to the next one, that is direct form 2 realization. Direct form 2 realization. So in direct form 2 realization, I have a minimum number of integrator blocks, minimum number of integrator blocks, minimum number of integrator blocks to be used. So in order to use these minimum number of integrator blocks, what do? So I just check the equation over here, that is y of t as minus 5. I mean, you are having 2 integrators, right? So I'll be using the number of integrator blocks, number of integrator blocks in direct form 2 realization is 2. Okay, so in the given problem, we go for the two integrator blocks there, right? So what do? I just have to draw two integrator blocks here. Integrator, yeah. So what is the output? The first one, the intermediate output, if I want to get, so that would be f of t. Okay, so that would be f of t. Now look at the equation quite clearly. Okay, so here if I want to use this integral f of t here, so look at the equation what we did. So this is the subsystem 1 component and this is the subsystem 2 component. So this is w of t. W of t, this function here would give me w of t. Okay, this is w of t. So you have to interchange the subsystem 1 and the subsystem 2 components, right? So what do? I have two integrator blocks here. So for the first one, I do the -5, which is to be multiplied, and this one is to be -4. This is -5 and this one is -4 here, right? So this is -5 and this one is -4. Okay, so now I have -5 and -4 after one integral block and the two integral block. So what do here? I have a summation being written here, right? So if I want to write it as a summation, what do? I use a summation and I just write it one more time. So this is plus and this is plus. So here, if you observe here, so this is x of t. So this x of t will be added to the output as f of t. Okay, so this is -5 integral f of t dt. This is -4 integrating it twice, that is f of t dt. Okay, so I have x of t also being present there. So x of t plus here. So x of t -5 integral f of t dt and -4 integrating it twice with f of t dt again. So that is having f of t here, and this is the first integral and this one is the second integral. After the first integral, I have f of t integrating it only once, and after the second integral, I have f of t being integrating it twice. So that is the direct form 2 realization. I have f of t being written as x of t -5 integral f of t dt -4 integrating it twice with f of t dt, right? So now I need to realize the output here, that is y of t. Okay, I need the output. So now what do? I have to use only one integral block because the subsystem 1 and the subsystem 2 component is being replaced. So after one of the integral block, I need to multiply it by only one to get integral f of t dt. Okay, so only after one of the integral block I'll be using, and I'll be taking the summation here and I can have the required output. Okay, so this is plus, yes. So y of t, so this function here would be the subsystem 2. I think I have not joined. Yeah. So y of t would be equal to integral f of t dt. Okay, integral f of t dt. So that's how you can get the functions. So this function here will come and f of t will act as an intermediate output for the subsystem 1 realization after it has been reversed, and f of t will act as an input to produce output y of t. So you have to be very clear in realizing the direct form 2 realization. That is quite required to have the function. Let me yeah, just a moment, we have a technical glitch. I'm sorry for the inconvenience. Let me share my screen again. I think we are experiencing a lot of technical glitches this time. I apologize for it. Okay, so we have realized the direct form 2 realization, that is using the minimum number of integrated blocks. So in order to realize the number of integrated blocks, so we have two integrated blocks that we had. realized here. Okay, so that is one thing that I want you to understand quite clearly. So in direct form 2 realization, we have certain things which needs to be followed there, right? So you are using the minimum number of integrated blocks. So in order to realize this integrated blocks, so we need to have an intermediate output f of t. Okay, so that is what I wanted to highlight. So most of them have a confusion where we have to directly go to x of t and directly sum it up or something like that. So please be clear about the way in which you are realizing it. Either it is direct form 1 or direct form 2. So in order to use the minimum number of integrated blocks, we will be specifying it for direct form 2 realization. Okay, so one thing where you will be going wrong is to have the integral operator. So how many times you have to integrate? It is dependent on the degree of the differential equation. Integrating it twice. So once, next, twice. Okay, so that is why I showed you step by step how do I integrate. Next, I need to have the output again, that is y of t. So one output y of t at the other way, and the other things which is there for the input, that is x of t being integrated or something like that. So you have one end, you will be having the output, and all other components you will be having it on the other side. So next, what you are going to realize, you are going to realize it by direct form 1 realization. So that is subsystem 1 and subsystem 2, both are being present there. Okay, so I'll be realizing it using direct form 1 realization and direct form 2 realization. So that is the number of integrated blocks that are being used. So that is in case of direct form 1, and direct form 2 realization we had already done in detail. So I think you are having a bit of idea regarding direct form 1 and direct form 2 realization. Okay, so now before winding up the class, I would like to give the problems here, exercises. You have to solve it, everyone. I mean, not everyone can solve it, but I'll be specifically saying for certain people. Y of n, that would be equal to minus 0.5 y of n minus 1 plus 0.1 y of n minus 2 plus 0.4 x of n plus x of n minus 1. So this problem, I think I can give it to Harshita. Harshita is there. Next. Next one, y of n plus 2 times y of n minus 1. That would be equal to 4 times x of n plus 5 times x of n minus 1. So this problem I can give it to G1. G1. Okay. Next, third problem, that is x of n plus 1/3 x of n minus 1 plus half of y of n minus 1. That would be equal to y of n. I can give this to Pawan Kumar. I can give this to Pawan Kumar. Okay, so you have to realize the above difference equations using direct form 1 and direct form 2 realization. Direct form 1 and direct form 2 realization, and you have to draw the direct form 1 diagram and direct form 2 realization diagram. Okay, so I think all the three will submit it within 8 p.m. today, and I need it to be done in a clear manner. You have to show it the blocks clearly, the summer blocks and the multipliers quite clearly. Okay, so moving on to the next one, that is the next set of exercise, that is, yeah, I think we had covered this problem. Yeah, let me take this one, which is dq, yes, plus 2 times d by dt of y of t plus 3 times y of t. That would be equal to x of t plus 3 times d by dt. Sorry, plus 3 times d by dt of x of t. Second one, what do I do here? So I have y of n. I think I had been specified this to I can give this to Nagraj. Yes, I'll be giving this to Nagraj. So y of n minus 1 by 4, y of n minus 1 plus 1 by 8, y of n minus 2, that would be equal to x of n plus half of x of n minus 2, that is there. I can give this to Maheshwari. Okay, so I can give this to Maheshwari. Fine. So realize these problems. I think I have a few more which I can give right now. So just a moment. Okay, so this is just the coefficients what I'm writing here. So you have to realize this system as this is the given difference equation as y of n minus a y of n minus 1 plus b naught x of n plus b1 x of n minus 1. Okay, so you have to realize it using direct form 1 and direct form 2 realization, direct form 1 and direct form 2 realization. Okay, so where the system 1 subsystem 1 realization should have y1 of n to be equal to b naught x1 of n plus b1 x1 of n minus 1. So this is the subsystem 1. So that is it needs to have this components where S2 system will have y2 of n, that is minus a y of n minus 1. So that is why the remaining output what you are going to have there plus this function over here you are going to have it. Okay, so that is how you can realize, and this problem will be solved by Prashant Veeru. Okay, so next one you are going to have 2 times y of n minus y of n minus 1 plus y of n minus 3, that would be equal to x of n minus 5 times x of n minus 4. Okay, so I can able to give this problem to Prithvi. I can be able to give this problem to Prithvi, yes. Okay, so I think she'll be able to realize using direct form 1 and direct form 2 realization. Okay, so this completes the block diagram approach. In case if I have a few more problems that needs to be discussed, I'll be sharing it in the next class, or else I'll be sharing it in your WhatsApp group. So see to it that you are going to solve a few more problems related to it and take it as a exercise. So it would be quite clear for you to understand where you're going wrong, what needs to be changed, or where the integrated blocks has to be replaced or something like that. So those small things I think you can able to figure it out on your own. Okay, so see to it that you are going to solve more number of problems in the upcoming class, and see to it that if you have any doubts, I'll be able to help you out. It is not like I'm just leave you or something like that. So see to it that the effort has to be there from your side. Okay, so I want the effort, and you need to understand the concept. I can have many number of problems to be done in the class, but if you don't understand the concept, I think it is not a good thing to have. Okay, so if you have any doubts, I think I'll be able to reach out to you, or else you will be able to reach out to me any time of the day, and you can have our discussion. I think we can have our discussion. Okay, so with this note, in the next classes, so we'll be having our discussion in detail with the Z transforms and few properties of Z transforms, and it would be quite easy for me to have Z transforms being done properly, right? You know a bit of Z transforms. I don't have to go in detail to the Z transform approach, and it would be easy for me to have the extension. Okay, so see to it that you are going to attend it and make the best use of the lectures that are there. Okay, so I wholeheartedly thank everyone for attending this session. Okay, thank you.